Hi, guys. So you have been working on kinetic energy for the last 2 weeks now. And so what we're going to do is we're going to take everything that you've learned and put it into practice. So you're going to actually be calculating your own kinetic energy now. You're going to have to be able to calculate and graph it for this activity. So follow along with me, background information. If you have ever been in a race, you know that not all people or objects travel at the same speed. If you know the distance traveled by an object and how long it takes, the speed of the object can be calculated using the equation speed equals distance divided by time. That equation is something that you're all familiar with. We were working with this equation for a long time. So, for a given mass, the kinetic energy of an object in motion can then be calculated by using the equation kinetic energy equals a half 0.5 times the mass times the speed squared, which is what you were just working on in your math connections. What I want you to do first is go through and answer these pre-activity discussion questions. And it's going to be you using the information that you've read about, that you've watched, that you've actually calculated for these pre-activity questions. So what is the relationship between mass and kinetic energy? If you're still not sure, this is something that you should know by now. But if you're still not sure, that's okay. I just want you to go back to maybe my answer key for the math connections, or maybe go back to that brain pop video, or even go back to your STEMscopedia. Question number 2, what other variable determines the kinetic energy of an object? So we know there's 2 things that determine the kinetic energy of an object. The first question already told us one of them was mass. So what's the second one? What is the other variable that determines kinetic energy? 3, how can we demonstrate the relationship between speed and kinetic energy? So the answer for question number 2 is actually part of this question right here. It's saying speed and kinetic energy. And we know that the 2 variables that determine kinetic energy are going to be mass and speed. So how can we demonstrate that relationship? How can we actually show it? Procedure. Find an open area and measure a length of 10 meters. If you round that, it's about 33 feet. Now, some of you might have a ruler at home, or you might have a meter stick at home. Some of you might not. What you can do is that your phone has different apps on it that you can get that can actually measure out different distances. If you still don't have that, real roughly, you can just measure steps. So you could just take like 33 steps, and we could use that as your about 10 meters. It's not super accurate, but in case you don't have the tools to measure. But if you have a ruler, if you have a meter stick, a yardstick, anything that can measure distance, even a tape measure, you can use that. Then you're going to mark off your start and you're going to mark off your end. And you can do that with tape. You could do that with chalk. You could do that with just placing a book and something else at the end. You just have to figure out your start and end. Step 2, perform each movement described on the table, time it, and record the times it takes for each one on the data table. So if I scroll down to the data table right now, the different motions that you're going to be doing, you're going to walk heel to toe. This will hopefully make it so that you're walking slowly. Then you're going to walk normally, and then you're going to run. And just for that 10 meters, that 30-ish feet, you're going to do those 3 activities. When you're doing that, you're going to time how long it takes. So you can use your phone, you can have somebody else use a stopwatch. You're going to time it, and then you're going to place that in your data table, and then you'll actually calculate the speeds. We're going to pretend like all of us have the same amount of mass, just because we want to keep that as a constant variable. We don't want that to change, because this whole activity is just exploring how mass affects kinetic energy. So we're just going to say that all of us are about 50 kilograms. Obviously, this is not true, but we're going to use this just so we can isolate speed. Then we're going to calculate the speed, and we're going to calculate out the kinetic energy. So your data table again, you want to put in your time for how long it takes you to walk heel to toe for 10 meters. You want to time how long it takes you to walk normally for 10 meters. And then you are going to time how long it takes you to run 10 meters. Then you'll put your time in. You're then going to take your distance divided by your time, and that's going to actually give you the speed. But we can't stop there. We're then going to have to use the equation for kinetic energy. So you're going to take 0.5 times your mass. In this case, it's 50 each time. And then you're going to multiply that by your speed. But remember, you have to square your speed. And that's going to give you your kinetic energy. Let me know if you have any questions. I am here to help. I will hop onto your lab with you. I will work directly with you.